For over a decade, enterprise information technology was held hostage by a monolithic design flaw, a physical multi-billion-dollar trap known as the three-tier data center. If you wanted to run virtualization software, you didn't just buy software. You were forced to buy centralized shared storage, massive physical storage area networks, or SANs. You needed them to enable high availability and workload mobility. And VMware capitalized on this physical hardware dependency with ruthless, terrifying efficiency. They built a multi-billion-dollar empire by positioning their vSphere hypervisor as the essential, inescapable control plane for these massive hardware environments. Enterprises were effectively forced to pay a dual premium. First, the exorbitant capital expenditures for proprietary fiber channel SANs, and second, the heavy, inescapable recurring licensing fees for the hypervisor required to manage them. It was a vicious cycle of hardware lock-in and software extortion, a SAN tax that drained IT budgets dry. Then, a fundamental architectural disruption occurred. In September of 2009, a team of engineers who had built the massive distributed systems at Google realized the physical SAN was an archaic constraint. They recognized that the legacy storage models governing enterprise environments were fundamentally incompatible with the rapidly scaling demands of modern applications. Led by Dheeraj Pandey, Mohit Aron, and Ajit Singh, Nutanix was born by collapsing disparate compute and storage silos into a single, distributed software fabric deployed on cheap, commodity x86 hardware. They pioneered hyper-converged infrastructure. They attacked the exact physical infrastructure VMware relied upon to justify its premium pricing. By rendering the traditional SAN obsolete through code, Nutanix quietly initiated the siphon of billions of dollars from legacy hardware vendors. They defunded the SAN tax and altered the financial calculus of enterprise IT forever. To understand how Nutanix systematically dismantled a monopoly, you have to look at the physics of their code and how that code perfectly aligns with enterprise economics. The founders wanted to bring web-scale architecture into the everyday enterprise. Instead of routing data across an expensive physical fiber channel network to a centralized array, what if a virtualized storage controller ran locally on every single physical server? This became the Acropolis distributed storage fabric, and its financial superpower is driven by a highly privileged localized engine called the Controller VM, or CVM. Inside this CVM is a choreographed symphony of distributed microservices. Each daemon process isn't just a technical feature, it is a direct replacement for million-dollar proprietary hardware components. You have Stargate, the primary data manager interacting directly with storage media. You have Cassandra, utilizing the Paxos algorithm to enforce strict consistency across the cluster, ensuring that a bank or hospital never loses critical metadata. Zookeeper maintains cluster configuration and leader election, while a background MapReduce framework called Curator continuously restores data health. But the defining performance characteristic, the one that allows this software fabric to outright destroy centralized SANs, is data locality. When an application executes a write operation, the hypervisor sends the request to the local Stargate process. Stargate writes the primary copy of the data directly to the local node's physical storage, while synchronously replicating secondary copies across the cluster. Because the primary copy of the data remains on the exact same physical server as the compute instance, read requests are serviced directly from local storage. They never traverse the physical network fabric. In optimal conditions, this reduces read latency to 0 milliseconds. To further eliminate bottlenecks, Nutanix rebuilt the storage write path using remote direct memory access. By passing physical network cards directly to the CVM, data transfer executes entirely in user space, bypassing the hypervisor kernel entirely and eliminating CPU-intensive context switches. Bursty random writes are absorbed by a persistent write buffer called the oplog, while sustained writes bypass it and flow directly into the extent store. This isn't just an engineering flex, it is a financial weapon. By achieving zero-latency reads and bypassing the hypervisor kernel, Nutanix proved that cheap commodity hardware powered by brilliant software could outperform million-dollar proprietary storage arrays. They erased the capital expenditure of the SAN, shifting IT spending from rigid hardware depreciations to high-margin software innovation. Recognizing the existential threat posed by Nutanix, VMware responded. They introduced VMware vSAN, a software-defined storage component shoved directly into the ESXi hypervisor kernel. On paper, it was hyperconvergence. In reality, deep architectural constraints left it highly vulnerable to inefficiencies that Nutanix systematically weaponized in the marketplace. The core discrepancy comes down to procurement economics and the concept of usable capacity. VMware's original architecture mandates rigid disk groups on each physical host. Every single disk group must contain exactly one high-performance flash drive dedicated exclusively to caching. But here's the fatal financial flaw: that cache drive does not contribute to the cluster's usable capacity. Its physical storage is strictly reserved, rendering it effectively lost from a usable storage perspective. Furthermore, vSAN historically required massive slack space up to 30% just for background operations and defragmentation. Nutanix, conversely, treats all drives in a cluster as a single global storage pool. There is no wasted cache drive. All flash drives contribute simultaneously to the persistent write buffer and the cluster's overall usable capacity. When you do the math, the difference is staggering. Analyses of identical hardware configurations reveal that VMware vSAN consistently yields 30 to 41% less usable capacity than Nutanix operating on the exact same hardware. For an enterprise procurement team, VMware carried a massive economic penalty. A customer running vSAN was forced to purchase significantly more physical servers and storage drives just to achieve the same usable data footprint as a Nutanix environment. And then, there is the blast radius. Because of VMware's rigid disk groups, if a single cache drive fails, the entire disk group fails. All the healthy capacity drives and the data residing on them are immediately taken offline. But Nutanix's global storage pool limits the failure domain strictly to the individual broken drive. Because Nutanix manages data in tiny granular 4 megabyte extents rather than massive, static objects, every single node and every drive in the cluster participates simultaneously in the rebuild process. This massive parallelization accelerates recovery times. Nutanix heals faster, uses less hardware, and yields up to 41% more capacity. The technical architecture inherently became a dominant financial pitch, destroying VMware's value proposition at the procurement level. But destroying the hardware SAN was only phase one. Nutanix still had to deal with the hypervisor monopoly. Initially, the distributed storage fabric relied on VMware's ESXi hypervisor to provide compute virtualization. This meant enterprise customers were still paying the vSphere tax to fully decouple the enterprise from VMware's licensing ecosystem. Nutanix developed the Acropolis hypervisor, or AHV. AHV is a highly customized Type 1 hypervisor built on the open-source KVM standard, but engineered for native integration with the storage fabric. And its most lethal feature? It is included at absolutely no additional cost. It permanently removes the per-socket and per-core licensing penalties associated with VMware ESXi. But migrating enterprise workloads from VMware to Nutanix is not merely a file transfer. It requires a deep translation of execution physics. ESXi was historically designed to mask resource contention through aggressive abstraction and complex scheduler juggling. AHV conversely prefers strict determinism and direct hardware coupling. When designing an AHV environment, architects must meticulously map non-uniform memory access boundaries. If a virtual machine crosses physical socket boundaries, interconnect latency spikes. Furthermore, CPU scheduling metrics had to be translated. In ESXi, you monitor ready time under AHV. This translates to steal time, the time a virtual CPU waits while the physical CPU services other tasks. Because the AHV CVM requires dedicated CPU cores to process storage I/O, architects must correctly size the environment for the CVM tax, the baseline CPU overhead required to maintain linear storage performance. Nutanix also had to master upgrade physics. They introduced the Lifecycle Manager to coordinate rolling, non-disruptive upgrades across firmware, the hypervisor, and the storage fabric. Taking a node offline triggers 3 concurrent distributed events within a strict 60-minute timeline: workload evacuation, storage rebalance, and control plane degradation. If an administrator rushes this process, the peak phases of these events overlap, causing severe latency spikes known as an upgrade storm. But by respecting the physics of the rolling maintenance window and maintaining strict data locality, enterprises achieve true zero downtime operations, protecting mission-critical revenue streams. For years, the architectural superiority of Nutanix steadily gained market share. But the true catalyst, the moment of mass enterprise defection, arrived in late 2023. Broadcom acquired VMware. Post-acquisition, Broadcom radically overhauled VMware's packaging. They eradicated perpetual licenses. They forced bundled subscription models like VMware Cloud Foundation for thousands of enterprises. By terminating advantageous license agreements, Broadcom effectively skyrocketed renewal costs overnight. This strategic shift created a Broadcom Reckoning, Infrastructure architecture was instantly transformed from a technical debate into a strategic boardroom-level financial mandate. The price hikes functioned as an accelerant. Chief information officers were forced to audit their deeply entrenched VMware dependencies. Nutanix was already positioned as the immediate enterprise-grade off-ramp to facilitate this mass migration. Nutanix unleashed a purpose-built automated migration appliance called Nutanix Move. Rather than relying on manual, error-prone exports, Move interfaces directly with VMware's vCenter APIs. The migration mechanism is highly deterministic. Move creates a migration plan and seeds data from the source ESXi VMs to the target AHV cluster, while the source systems remain completely online in production. It synchronizes delta changes every 10 minutes, ensuring minimal data drift. Prior to the final cutover, the tool automatically injects KVM Vertio drivers and Nutanix guest tools into the guest operating system. The cutover process powers down the source, disconnects network interfaces to prevent IP conflicts, and powers on the target in AHV within minutes. Furthermore, a AHV utilizes redirect on-write snapshots, which differ significantly from VMware's copy on-write snapshots. VMware's deep delta chains severely penalize performance. Nutanix's snapshots carry zero performance penalty, allowing enterprises to secure mission-critical databases every 15 minutes without inducing application latency. Nutanix Move wasn't just a technical convenience, it was a financial life raft for CIOs drowning in Broadcom's new pricing models, automating the exodus at scale. Over a multi-year period, Nutanix deliberately navigated one of the hardest maneuvers in the technology sector, transitioning its business model from selling proprietary hardware appliances with perpetual licenses to a pure-play software subscription model. Wall Street analysts initially struggled to map this transition. Legacy revenue metrics temporarily dropped as the company built a highly predictable recurring revenue engine. But by fiscal year 2024, the transition reached an undeniable inflection point. Nutanix achieved its first full year of positive GAAP operating income, generating $2.15 billion in revenue and $598 million in free cash flow, nearly tripling the prior year's output. By fiscal year 2025, even in the face of macroeconomic tightening, the breakout was complete. Total revenue hit $2.54 billion. Free cash flow reached $750 million, driving an exceptional free cash flow margin of 30%. They achieved a Rule of 40 score of 48, a definitive hallmark of an elite, hyper-profitable software engine. As of mid-2026, Nutanix stands as a highly profitable software juggernaut, boasting annual recurring revenue of $2.43 billion and a staggering non-GAAP gross margin of 87.8%. They used this massive cash position to enact aggressive, shareholder-friendly capital allocation, authorizing a $750 million share repurchase program, and they are rapidly expanding the fabric. Rather than competing with public hyperscalers, Nutanix integrated with them. Nutanix Cloud Clusters allows enterprises to run the exact same AHV hypervisor on bare metal inside AWS and Azure. With GPT-in-a-Box 2.0, they are delivering turnkey, sovereign AI inference natively on AHV nodes equipped with high-end GPUs, allowing heavily regulated industries like finance and healthcare to run local AI without building disparate shadow infrastructure. Looking forward, executive management projects, a total addressable market of $137 billion by 2029. Nutanix didn't merely build a software product, they fundamentally re-engineered the physics and economics of enterprise infrastructure. By commoditizing the storage layer, they stripped away the physical foundation that justified VMware's premium ecosystem. By delivering a native hypervisor and an automated translation engine, they dismantled the software lock-in entirely. The code that broke the SAN monopoly didn't just defund a massive hardware tax. It has ultimately matured into the foundational operating system of the modern enterprise cloud. If you want to understand the architecture of the next decade of technology, subscribe to the channel and hit the bell so you don't miss our next deep dive into the code that runs the world.